Alright, so before I get into day 9, I'd like to talk about flowcharts, which are a very nice thing that a lot of us scripters like to use, and not even just for programming, but for other tasks. Flowcharts are very helpful, and they're used to pretty much map out any set of things that you want done. Like, for example, you can make a flowchart for making a peanut butter sandwich. Now, in this case, because everything past week 2 is going to be somewhat more complex and difficult, I'd like to introduce making flowcharts to map out how exactly the daily task or daily challenge is going to look like. So as you can see here for day 7, I made an example flowchart which was for the checkpoint system, and I'd also like to get into flowcharts themselves and how to make them, because it kind of has its own syntax in a way, but it's mainly just so flowcharts are easier to read. So right here, I have these two little boxes. These are called swimming lanes. They're kind of just organizers for different segments of a flowchart. So in day 7, this swimming lane here, there's a couple of things going on. These these very rounded edge bean looking blocks right here, these are called terminators, and they're pretty much the start point and the end point of your flowchart of your system. So for day 7 here, our terminator is retrieving the player. This is what starts the flowchart. And then these arrows indicate what happens next in the process. In this case, it leads over to this diamond looking block. This diamond block is called a decision. This is what splits off the flowchart into two different branches. So in this case, this diamond here is, does the player touch an obstacle? And there's two different branches. There's yes, and then there's no. In this case, the yes here is green and the no here is red, right? So now, once it branches off into these two different things, we'll go with the yes path first. It'll then go into this blue square right here. This blue square is called a process. It's just any single thing that's going to happen. In this case, our process is going to be resetting the player's character. From there, it then goes into this cylinder. Now, this cylinder is the database. This is where we pull and add data. In this case, we're retrieving the player's last save checkpoint from the database, in which then we're going to place the player's character to their last save checkpoint, which is shown by this blue square here. Now, I also am not a master at flowcharts, so there could be a better representation for how the data part of this flowchart might go, but as long as it's conveying the general idea that we are getting the player's data and then putting it or taking it into use, then that's all that matters. In which case, then the code follows up into this triangle here. This triangle is called a merging block, and it's what's used to symbolize that any processes that were separated by a decision or a split process are now converging back into one main series. So following back where we went to the first decision, in this case, if they say no, the player has not touched an obstacle, it'll then go into another decision. Has the player reached a new checkpoint? If they have reached a new checkpoint, then we're going to update the player's last save checkpoint to the new checkpoint that they've touched, and then they're going to hit this merge block. And as you can see, this is a process because we're doing an action. Now, if you'd want this to be even more descriptive, if the player has not reached a new checkpoint, you would add a no statement here, in which that no statement would go back up to this decision up here. In this case, I didn't do that just for simplicity because the idea is being conveyed here. Then, at the end of this merge block, it puts us into the terminator, which is our return processes, and that ends the flowchart. In this case, return processes are things that would happen after the code that would be sent back once the code is completed. the function. In this case, these return processes are whatever would happen in the rest of whatever this checkpoint system is being used for. I hope that made some sense, but I'm trying to get this as simple as I can. If there's any other confusion, you can always Google it. As for what flowchart software I'm using Lucidchart, as you can see right here. I would highly recommend using Lucidchart. It is a great tool for making flowcharts and other models and diagrams. It's really awesome. Though there are some other free alternatives. There's one called draw.io. It's an application, and then there's also one that the official Roblox uses. I think it's called like TLS Draw or something like that. Anyways, let's move on to day 9, which is going to be our timer system, where I'm going to have I've made a flowchart here for how the timer system is going to work. In this case, the start is going to be the timer is being initialized. So we've called the start of the timer. In this case, we have a process here saying call timer module to start ticking down. So we're going to have a module script that can be called to begin a timer. And then we have it splitting off into 2 different arrows. Now, if you look back here, you'll see this is this is a decision, and the decision is saying yes or no. This splits the code, or not the code, but the process, the series, into one different line. What this does is it branches out the series into 2 separate lines. So they both run simultaneously. If it were to branch out into one specific line, it would either be a decision or just an arrow moving down to another block. So in this case, it splits off into 2 separate but same running processes. The first one is we're going to fire all the clients and send the timer data for the timer UI that the player is going to have on their screen to indicate the timer is ticking. And then we also have this one where the timer module will return a function on completion. Both of these go into a merge block, which then goes to the end. Now, you might be confused here. Why is there an arrow going from here to here if there's one arrow going from here to here? And that's because we can fire all of the clients before the timer module is completed. This can always happen before. So if it does happen before, we don't want to end the process immediately. We want it to return back to serial. And in this case, serial means everything's running in order from top to bottom, while parallel means things are running side by side. Because if we end the function before the timer is completed, there's going to be an error. And that's the flowchart for day 9. As you can see, it's pretty simple, and I will try to make a flowchart for every single day following after this to make sure that it's explained pretty well. So we're now running on, day 9 of the 30-day scripting challenge, and it's once again, it's going to get a lot more advanced here. We're going to be moving into another crazy topic. If you're new to scripting, it's going to be crazy, but if you're not new to scripting, it's not going to be crazy. It'll be like everyday tasks, right? So for day 9, it's going to be a timer system, and we're going to get into module scripts for this one. And I love module scripts because we can set up game architectures or frameworks with module scripts here. So in replicated storage, I have a folder called modules that I made beforehand, as well as this UI up here called 30 seconds up, which is how our timer will display information. But I'm probably going to rename this from modules to services, and then inside of the services folder, we're going to make another folder. Probably call it like some kind of like identifier for services. I usually just say services, but I need to make this. So we'll just call it custom services for now, and then we'll have the folder called services, which for now I don't think I'm gonna do this. Sorry, I'm wasting a lot of time. I didn't really have a script for this video. We're not gonna do that. I'm not gonna show like a full framework here. We're just gonna call this services, and in here we're gonna put a module script, and we're just going to call it the timer service, which is pretty much how our timer is going to be handled. Alright, and then we have this. We don't exactly need to use this right here, but we can. We're just going to say timers, or no, we'll just say timer service, and then, yeah. I'm too lazy right now, but okay. So the way timer service is gonna work from the flowchart segment, we're gonna have like 4 functions, which is so function timer service dot create dot start timer, and then our duration, and then duration has to be a number, and then it'll return a string, which I will get more into in a second. I'll explain what for this thing right here. It's going to have the function, right, the parameters, and then you can use this colon here, which will tell you what each parameter has to be, and then outside of the function there'll be another colon, which will tell you what the function will return. In this case, it'll return a string, and I'll explain what that string will mean. It'll act as like a key for the timer. So we're just going to say local here. Let me first get HTTP service. And pretty much what we're going to do is we're going to use a tool in the HTTP service called generate UID. It is going to be HTTP service called generate GUID, and then false, right? So this is going to pretty much act as our key for how we're going to access the timer inside timer service in case we need to like pause it or add more time to it. And then we're going to say timer service, and then because timer service is a table, the UID is going to equal a table. We're going to make a dictionary here, and we're going to have a couple things. We're going to have the duration will equal the duration, and then remaining will equal the duration because we're just initializing it right now, and then our finished, which will equal false. And that's going to set up our timer, and now we're just going to begin the loop here. So while duration is greater than or equal to not duration, while timer service UID dot remaining is greater than or equal to 0, and timer service, well, actually, just to save some time here, we're just gonna, no, actually, never mind. I was gonna make a variable for timer service UID, but I'm not gonna do that. And timer service dot UID dot finished. We'll actually say and not because it's a boolean. Then, oh sorry, not then. Sorry, brain's not working today. So what this while loop is gonna do is it's gonna check if I'll rename this, by the way, to key, so it'll visually make more sense. So the key is how we're gonna identify what timer we're using. What timer is what timer, right? So while the remaining, which is going to be a number, is greater than or equal to 0, greater than 0. Sorry, another mistake. While it's greater than 0, then we know the timer is still ticking, and the finished boolean is not true, meaning that it's not done, right? We're gonna run this, right? And what's pretty much gonna happen, we're just gonna check. Because we're using a while loop, we can move the boolean check into an if statement, which I actually am going to do. So we're just going to say, so we'll delete that entire line. And the reason why is because we're using a while loop. If, say this is like, if timer service like key remaining, if it doesn't, like, if we delete this value and then add it back later, the loop will stop and it won't continue again. And to make sure this loop will end when we want it to end, I'm also gonna add another like check in here. So while timer service key and timer service key dot remaining is greater than 0. So check if our timer exists and it's greater than 0, because we're gonna end up we're gonna set this to nil once the timer is done, so we could save storage, right? We're going to check if timer service key dot finished, if not dot finished. Then, so if the timer is not finished, then we're going to wait 1 second, and then we're going to set the timer service key dot remaining will minus equal 1. So we're going to take off 1 second from the remaining until it'll equal 0. Now, to make sure this loop continues, we're going to add an else. We're going to have a 0.05 wait time. I don't know the term for this, but there's like 0.05 or just like 50 milliseconds. It's like, I think it's called like the CPU idle time. I don't know the term for it, but I know there is something like that. I could be wrong though, I could be like tripping, but this is just like to make sure that the loop isn't eating too much of our resources when the timer is not running. So that way also, if timer service thought, I'm sorry, I just had like the craziest trip up ever. not finished. It's running. Sorry, like this early into the video, and I'm like already like tripping on myself. It's running, not not finished. It's running. Sorry, I'm actually sorry. Change it to running because we're not trying to check if it's finished. We're trying to check if the timer is active because we're gonna pause it. So if the timer is running, then we're gonna do it out. If it's not running, then we're gonna run this, right? And that's pretty much our start timer. And then we're going to return the key so that way that we can access this data later. So now that's our start timer. We're gonna have a function timer service, and instead of using dot, we're gonna use the colon here. So it'll be colon pause, or actually not pause. We're just gonna say just timer, and then it's going to need one value, which is our key, which has to be our string. And what this is gonna do is what just timer is going to do is it's going to check if moving is equal to true, then we're going to have the timer like start. If it's false, that means we're just going to pause the timer. So it's practically going to be the way to pause our timer. So we're just pretty much going to check if key, or we say if not key, then return end, or just say if key, then. Or we can also do another one. We'll just say, actually no, if key, then we're gonna say not this. So the reason why we're using the colon here is because it'll automatically pass in the self variable here, which is why we want to use it, this self thing right here. Because if it's not in a colon and we put self, it's not gonna work, right? So using colon, it'll automatically pass in the self. So we can just say it'll automatically pass in timer service, the module, right? Sorry if I'm explaining this bad, but it automatically passes in the timer service itself. This gets passed into the function, right? So we can say self key dot running is going to equal to the moving, which has to be a boolean, right? It will equal the moving, and that's it. That's literally all this function will do. Now you can also just like remove the key, like this key check if you want, because I know like the key, but it's a safety check. It's fine. All right, and now we have that is our just timer. So it'll be our start and stopping, like a pause and unpause, and then we have our we can either make a function to clean up. Well, actually, no, we need to have a cleanup in here. So to simply put a cleanup for the timer in here, we can just say if, what was the variable for it? I don't freaking remember. Shoot, timer service, if the timer service key dot and timer service key dot remaining is less than or equal to 0, or in this case just equal to 0, because we're not the thing won't continue if it's equal to 0. So we'll just say if it's equal to 0, but we'll just do less than or equal to 0 for simplicity, right? Then we know the timer is done, and then we can just say we can have whatever callback we want to happen in case the timer is done. So in this case, actually, what we could do is we can pass in a second value inside of our function, which will be called the callback. And yes, you can pass in functions as parameters. And to define this parameter as a function, you would just put you'd put the parameter in, and you'd add the parentheses in there. And it would automatically define this as a function. See, in here, it already has the parentheses around it, so it's a function, right? And I'll explain more as to why we want to pass in a function as our second variable once we get to the server side thing, right? So now our last function will be the ending function to destroy the timer. So we can just say function timer service colon remove timer, and then our key, which has to be a string. We're simply just going to say if key, then self key will equal to nil, and that's literally going to just destroy the timer completely. Pretty simple, and that's practically all we need for our timer service. And then also one final thing I forgot to mention, because this is gonna be like a loop here, we don't want the code to halt until this loop is satisfied. We want it to kind of run in the background like with our code. And to do that, all you just do is this function called task.spawn, which will create a coroutine pretty much, which in like simple terms, means the code's gonna run next to each other instead of all like from top to bottom, if that makes sense. The term for that is serial, but yeah. Alright, anyways. So putting this test spawn means it's gonna call this function and it'll run this, but then it'll also run the end statement here. So it'll automatically go back to the like whatever it was doing before. And then this callback will also run once the timer is finished. So the code won't halt for this timer, if that made sense. So that's literally all the functions that we need for our timer service. It should now run perfectly fine here. Hopefully, if not, I'll just do some quick bug fixing. So now we'd pretty much I've also made 2 folders in server script service to organize everything. There's week 1 and week 2 because we're doing a lot of server scripts, and then in week 2 was the NPC drop script. If you're not in the 30-day scripting challenge, then it doesn't matter. Don't follow me on this one. We're gonna make a server script right here, and it's just gonna be like the server end. So it'll be timer service, and then we'll just put timer service. No, actually, no, we're gonna say server. And then we're going to reference the timer service. So we're going to say local timer service is going to, let's get replicated storage first. Local replicated storage will equal to game.replicated storage, and then local timer service will equal require replicated storage dot services dot timer service. And now if we want to start our timer, we could just say game.players.player added connect function player, and then player character added wait. And what this will do is it'll wait for the player's character to fully load in, and then it'll run the timer. And to anyone wondering, when you have a function block like this, not function, forgot what these were called. These things right here, you can, instead of doing connect function, you can just do wait, which will halt all of the code until whatever this thing has been satisfied. So if you're waiting for the player's character to load in, you can say wait, and it'll halt all the code until the player's character has been loaded. And then now we know the player's character has been loaded, we can start the timer. So we can just say local timer will equal to timer service timer service dot start timer, and then our duration, which will be 30 seconds, and then our callback, which we're just going to say function, and it'll be passed inside of the parameter. So now all of the stuff we put inside of this function block will run when this module script calls the callback function. In this case, what the heck? We can just say print timer has been completed. And we can also have the remove timer called here, or we could just say, we could either have the removing process be happened here or on the server. Because we already have that removing function, I'll just do it here. I'll just say timer service remove timer, and then our our timer right there. Actually, I'm a little bit stupid because the timer variable hasn't been set yet. This is a callback function. But yeah, this will have to the callback has to happen here, so we're just gonna say we could do this or we could call this function, but it doesn't matter. Yeah, and that's how the callback side of this is going to work. Now, if we want to talk to the client, if we want the client to be aware of the timer, what we can also do is we can have this communicate to the client. So we can go into whatever client side you want. In this case, because my timer is in Starter UI, I'll just put the script here. But local script, and it'll just be called timer service client. We can now send over the information. Now, previously I had remote events predefined inside replicated storage. This time, we're not going to do that. We're going to create the remote event. We're going to make the remote event so that way the player can wait for that remote event to fire. So some frameworks do this, but yeah, this is what I like to do. So we're just simply going to say, so we're pretty much just going to check inside replicated storage when a child is added. So we're simply just going to say local replicated storage is going to equal to game.replicated storage, and the replicated storage our child added connect function, and then our child that's been added, and we're going to say if child colon is a remote event then. And then from here you can run any other logic for receiving like remote events created on the script. But in this case, this is only going to be used for the timer. We're just going to check if the remote event is the one we're looking for. If the child colon is a remote event and child.name is going to equal to timer is equal to timer data, then so if the remote event is the specific remote event we're looking for, then we're going to run whatever code we want here. In this case, we can create a local function up here or just have the code that we want run here, but I can make a local function right now. So what we really want the client to do is just update the UI for the timer, right? So we're also going to grab the timer service. So local timer service will equal to require replicated storage services dot timer service. And from here, we're just going to say local function run function update timer UI, and then our data. So in this case, because we're sending a table of data, we're just going to say, actually, wait, what were we sending again? What were we going to send? The key. Yeah, it needs a key. We're going to check child dot on client event colon connect, and then the function which will have the timer data, or we're just gonna call it the key, which is a string. Actually, no, just have context. The key right here. And then we can just call the update timer UI with our key parameter here, which in this case needs to be a string. And that's pretty much that. We can now just run our timer service thing. So in this case, we might also want to have a backup, which is going to be what our running type is. You can do this with strings or integers like 0, 1, 2 to like indicate what each number is doing. But I'll put in a string if we want to know if the server is like starting the timer, stopping the timer, pausing it, or unpausing it. So we're going to send in a third value with our thing to expect a third value, and that's going to be the action, which I will show how you could do this with numbers, because it'll probably not like an integer. Oh, they don't have those. Okay, probably just a number, right? Because in plain theory, it'll look like this. So 1, it'll mean start timer, right? 2 will mean stop timer. 3 will equal pause timer. 4 will equal unpause timer, if that makes sense, right? So we're going to send in our key and then also our action, but I don't need to put context in here. Here needs context. So action, which has to be our number, right? And now this is what we're going to do. We're going to check, first of all, if key, then, if the key exists, then we're going to run this code. But we can also have this if key check right here. It doesn't matter, right? Oops, I don't need to open you. So now let's begin our thing, right? So if action equals to 1, then else if action equals to 2, then else if action is equal to 3, then, and then else if action is equal to 4. Now, if these were strings, you would replace the one with like the whatever the string would be, right? I didn't put the thing there. All right. So action 1, this is going to be starting the timer. So we're simply just going to say local timer is going to equal to timer service colon. I didn't make a function here to get the data. That's my fault. Function timer service colon get timer. And then I swear I thought I made this, but I actually didn't. That's my bad. We'll go ahead and make this, and then it's going to return a dictionary, and it's just going to say return self key. Sorry, I thought I made this, but I didn't, and that's pretty much how that's going to work. So timer service colon gets timer, and then in this case we're going to pass in our key, and it's going to give us the data. No, actually I did that wrong again. In there's a thing called run context, where the module script being required on the server will be a different module script than the one required on the client, meaning they're like the data stored inside of them won't be the same. So the key doesn't actually matter. It just needs to be the duration that we need to send. So instead of putting the key over, we're just going to send the time. We'll just say duration. We're not gonna send the key over. And then the duration needs to be a number. And then we're just gonna say timer service dot start timer our duration, which is going to be the duration value, and then we do not want a callback. So to make sure that there's like safety for this, we're just gonna say if callback, then we're going to run the callback. If there's not a callback, we don't want to like not run anything. So we could just like put a function in here as a callback, but like once again the client is going to do anything. But yeah, unless you want the UI to change after the timer's done, then yeah, we could put a thing here where we could just say stuff. So now let's also grab our UI, which I forgot to do. So local timer label is going to equal to script dot parent dot timer, and we'll simply just say timer label dot text is going to put like game over or something like that, because the timer is finished, right? So now that our timer has started, we're going to now start making the UI of the, we're going to grab run service. So to just say local run service is going to equal to game get service run service. And the reason why we're going to do this is because run service has a function called is client or is server or something like that. And in our loop here, we can put a check where it's going to determine if run service is client, then, and also we're going to have a third value, which is going to be whatever like timer label we want to change. So we can just say label, which can be a text label, right? That's going to be our label, which we can change. And if it is client and there is a label, then we're just going to say label.text will equal to time remaining, and then we concatenate it with timer service key dot remaining. So what this is pretty much going to do is going to check if we're running on the client. So if the client required this and there's a text label that needs to be adjusted, then it's going to adjust the text of the thing. And also we probably should put this inside of our if timer service dot running. So we'll put that right there. So it'll only change the text if it's running. And if it's not running, then we can like have it say like timer paused or whatever, but we're only gonna have it adjust the text if it's on the client. So here we can put in our function, and then we're also going to pass in, and then because where the variable function works is this entire thing is the variable, we're gonna have to put a comma at the end here. But in this case, I'm probably just gonna move the callback over to the third spot. So we're just gonna move the callback here, and then in our timer service, we're just going to say nil because we don't have a text label, and then our callback. So then that way we can put in the timer label and then our function instead of having to put it right here. This is only a visual thing, it's not going to affect the code. So duration, our label, and then our callback. So we have our duration, our label, callback, and then duration, label, callback. And that's pretty much all we need for if action is equal to 1. Because our module script will change the text label for us. Now, for action 2, this is going to be if the thing is being destroyed, which we'll just simply say, if it's being destroyed, we're just going to set that thing to equal nil. In this case, I'll have a variable on the outside. Now, when we're using this timer service, by the way, it's important to know that we can create timers for multiple things. Like, we can have a game timer and then cooldown timers for abilities. In this case, if we wanted it to be, like, defined as to what timer we're sending, whether that be a global timer or a independent timer, we'd have to send over what is on cooldown. In this case, it's a global timer. We're just going to set the global thing to be on cooldown. So we're going to have the global time right here. So I'm just going to say local timer, and then we're just going to have the timer be set to that. In this case, us timer is going to equal to nil because right now it doesn't exist, and then timer will now equal this right here, right? This is for our global timer, the one that's going to be for the entire round. For abilities, it would be creating its own like separate variable. So what you would do for that is you would just say local ability timers would be like a table, and then you'd access each ability and get their timer from there. Or the server could just send that data over to the client and they'd only update the visuals, which is kind of what we're doing right here now. So if the action's equal to 2, then we're simply just going to say timer will equal nil. By that I mean timer service remove timer, which we'll just set it to equal to nil, and then we'll put in our timer variable. If it's 3, we're going to pause it, so we're just going to say timer service adjust timer, and then the key, and then because we're going to pause it, we're going to say false, and then timer service adjust timer, and then true. And that's pretty much all we need for the client. It's going to update the text for everything, and the timer should naturally start ticking. So we're going to now add in the remote event. So we're going to say local send timer remote will equal instance.new remote event, and then send timer remote dot parent will equal replicated storage, and then send timer remote dot name will equal to whatever it was here, which was timer data, and then send timer remote fire all clients. Now, instead of running fire all clients, if you'd only want this timer to run to players who are like in the match, you would run a loop through all the players in the game to check which one has a value set to true, a boolean value, which would be like if they're in the game, to true or false, and then fire to that client individually instead of all clients. But doing this for simplicity, we're only showcasing the timer system itself, right? Now with that, it's going to fire to all the clients once the timer has been initialized, and then the player is going to receive it, and then it's going to set this update timer, and also we have to pass the values, in this case the timer, not the timer, the duration, sorry, I keep forgetting, 30-second timer, and then the action, which we're not going to have, it'll just be 1 because, you know, that's what it's going to be. Now usually I would have this be a string so that way you would know, but 1, 2, and 3 to keep it simple, and I could probably like add comments here, it doesn't matter. So that's pretty much that. It's going to wait for when a child's added to replicate storage. If it's a remote event and it's the same as timer data, then it'll wait for it to be fired. It'll send the duration, the action, and it should start changing the timer's text. So let's give it a try and see if it'll work. It was not working, so let me go troubleshoot real quickly. Okay, the issue was this was running too quickly, so the thing wasn't running, so I just put a print here to check if it was adding or not. And then I just had a task.wait 1, so it would wait for the player to fully load, and then it would start running for the child added. Because what's gonna happen is what was happening was because the player wasn't loading like quick enough. This was running before, and it was putting this into replicated storage, and then this listener here, this child added, started after. So by the time the remote event was added to the thing, this hadn't started running. So now when we play the game, it's going to say time remaining, and then the timer will start ticking down on both the client and the server. So what if I wanted to do is I could go to the timer service and I can put an else right here. So if it's not running on the client, I can say print and then timer service key dot remaining. And I can just say time left and then concatenate that. So it's going to say 29, 28, so it'll both be on the same thing here. Now, if I wanted to do some stuff, like test out the other system, so we can now just say task.wait 5 seconds, and then I can now say timer service adjust timer, and then we're going to send in our timer, and then moving. We want it to stop, and then we're just going to say send timer remote fire all clients, and then the data we're sending, which is the duration doesn't. So if duration or action is greater than 1, then because we only use duration for the first action, so we can say if the duration or action is greater than 1, so that way we don't have to always send a duration. We'll say nil for the duration, and then our action, in this case, because we are pausing the timer is going to be action number 3. We'll send in the number 3 here after 5 seconds, and then we're going to put a task.wait 5 right here, and we'll say timer service colon adjust timer and then unpause it, and then because 4 is going to be our unpause timer button. So also give that a try. Okay, the timer is ticking down. 29, 28, 7, 26, 25. Now okay, it's not stopping. So give me a second. So I actually made a critical mistake here with using the callback inside of the timer variable, because we can't access the UID. What we need to do is take the task.function out, task.spawn function out here, and then we need to put the task.spawn in the while loop right here. We don't want it to be in the entire thing, or else it'll skip the return key thing here, which is what we want. So now, if we run it, it should print out our timer data, and now it'll stop at 25. Okay, it stopped at 26. That's right, it stopped at 26 because we only want the visual data to happen after. So the -1 should happen first, but the task.wait should happen last, actually. We'll just move you down here. The task.wait needs to happen at the very end, and that should fix it, pretty much. So now let's test it one more time. And by the way, this is what a UID looks like. Yeah, and it's not stopping at 25 once. Okay, I'm super duper stupid. It is working fine. It is ticking down 5 seconds. It's the way this is working is it's starting the 30 seconds, like the 30. So if you look at the print statements here, saying time left 30, and that's second 1. Time left 29, that's second 2. Time left 28, that's second 3. Time left 27, that's second 4. And time left 26, that's second 5. It's starting it at the top of the 30 seconds, not the end of the 30 seconds. So it should realistically be the 29 here, if you wanted to start at the top of the 29. So it'll start at 26, it'll wait 5 more seconds, and then it should unpause it. Now, as you can see, it's going to continue going and ticking down, and yeah, that's pretty much it. So now if I wait all of the remaining seconds here, alright, and now it should say game over. No, it's not. Okay. So I think this if statement should also go in the task.spawn. Everything else should go outside of it. And then I think I was right before. This should happen before the decrement, not after. I think that's what was one of the issues. Alright, so that should work here. So let's, there we go. So 10, 9, 8, 7, 6, 5. That's right, it's gonna wait 5 seconds because I didn't take that out. 3, 2, 1, and that says game over. Timer has been completed. So let's go back here to the timer service thing, and I'm just gonna take out all these blocks here, and we're just gonna run one more time. And I changed it 10 seconds for debugging. So those are the changes I made, by the way, those two. So it goes from 10, 8, 7, 6, 5, 4, 3, 2, 1, and then it says timer has been completed. And that's the timer module, basically. Sorry I'm like half asleep when I'm recording this. I just I'm very sleep deprived for some reason. This is getting into module scripts now, and we're gonna do, I might go into like frameworks, like how you can have games be made off of module scripts only. I might not, but I will definitely go into making custom services like this timer service here. And this alone is pretty much the important part. These two scripts here, the server and the client, they're only just like receiving ends that can be used for something, right? This is like the main body. This is what gives you the actual timer that can be utilized. So in this case, I was using it for a global round timer. If you had like a bunch of abilities that you wanted the player to have a cooldown for, you would create an individual timer for each ability, and for their labels, you wouldn't pass in this global timer label. You would have it search in the player's UI for the specific timer label that needed to be changed. So you'd pass in a value which is going to be the ability, and then it would look for the abilities UI in the player's GUI, which it's not that complicated to do. I'm just really bad at explaining things, but this is the main idea of today, which is making a custom service and having it be a timer service that'll decrement and do whatever it needs to. And then in this case, because I did pass in the label that needed to be changed with a timer, you can also pass in the text label of whatever ability you want, and it's gonna work perfectly fine. And then this is an optional print statement that doesn't need to be used. This is just so you can compare the server and the client's times. So yeah, thank you all for watching day 9. To anyone who stuck around, I'm seriously gonna try to get my uploads together. And though this might not be exactly like how the flowchart looked like, it's a natural process when coding where you might like use your flowchart as a base, but then you build off of your flowchart or maybe change things too. Now, I wouldn't do that though. If like you have a client and they said that they specifically want this, you should give them what they want, or ask them if like they'd be open to having some things like slightly differentiated. I will put this service in a paste bin. This timer service here. These two I will not. This is just my receiving end that a paste bin is not needed for. Alright, thank you all so much for watching. I'll see you for day 10, which I definitely will upload really soon, because day 10 is gonna be fun. Day 10 is going to be damage zones. So if you've ever played like an adventure game, you'll know that you can go into like water, where water will slow you down, or like poison or mud or whatever, and that is going to be fun. I will definitely get to that very soon. Alright, thank you all so much for watching, and I will see you all in day 10. Alright, so this is after I've recorded the day 9 video. I forgot to include one important function, which is adding and taking out time from our timer. Like, for example, if the match goes into sudden death, which is when the timer reaches 0, we want to add an additional minute to the timer, like as done in Clash Royale. And I completely forgot to include that function in the original video, so we're going to do that right now. We're going to pretty much create a new function, which is going to be to add time to the clock. So it'll be function timer service add time, and then the amount of time that we want to add to the function, and we're pretty much going to say self key dot, and then our remaining dot remaining will plus equal the time. In this case, it should probably be, we'll change it to adjustment. So in this case, if the adjustment is negative, then it'll remove time from our clock. And we're going to go back to our server script here, to week 2, to the timer service thing, and then also back to our client script. So we can add an else if action is equal to 5 then, so duration, and then adjustment, which needs to be a number. Alright, and then we're just simply going to go to the timer, and we're just going to say timer service adjust timer add time, and then our timer, and then our adjustment, which will be the adjustment. So now if I want to have the timer like add 5 seconds or move 5 seconds, we'll just say task.wait 5, and then we're going to say, what was it? It was I'm going to say send timer remote fire all clients, and then the values we want to pass are the adjustments. So we're just going to say nil, and then our adjustment will be 5. So we're also going to say timer service add time, and then our timer right here, and then our adjustment, which will be 5 seconds, will be added to the clock, and that should now act as our, and it added time but not to the UI. Oh, that's right, we need the action. The action's 5 as well. Forgot about that. Okay, 7, 6. Okay, then it adds the time. Needs. Alright, perfect. And that's